The Schlenk line is used to make organic synthesis easier and efficient when working under nitrogen and dry conditions. There is a tube from the nitrogen source with a pressure regulator to a drying tube. The nitrogen flows through this drying tube to remove any water that may be present. It then flows from the drying tube to the Schlenk line. At the end of the Schlenk line, a tube is connected to a bubble counter. The excessive pressure can be carried off and you can see how fast the nitrogen flow is. A second tube connects the vacuum to the Schlenk line. Close all taps of the Schlenk line by turning to a horizontal position. Turn the vacuum completely open. Adjust the nitrogen flow until approximately 2 bubbles of nitrogen per second are released. Monitor the flow of nitrogen continuously during operation and adjust to maintain this flow level when needed. Check if there is a vacuum when the black wing of the tap is in the upright position, and also if there is nitrogen flowing out of the taps when the wing of the white tap is in the upright position. You can check the vacuum by touching your finger to the end of the tubing, and you should feel the suction. The nitrogen flow can be checked by feeling for the flow of gas or using a piece of paper. Set up the equipment as you have learned. Close all inlets and outlets with a stop or septum. Insert a needle through one of the septa and attach it to the Schlenk line. Remove all plastic clamps and the flammable materials from the fume hood. Light a Bunsen burner. Turn the black wing of the tap to the upright position to turn on the vacuum on the Schlenk line. Warm the glassware gently with a noiseless blue flame. You will see any condensation slowly disappear. Take care not to melt any plastic parts by keeping the flame away from them. Passing the flame over the glasswork a few times is enough to dry it. Turn the nitrogen tap of the Schlenk line to release the vacuum from the Schlenk line and fill it with nitrogen. To do this, turn the black wing of the tap to the downwards position. After a few seconds, close the tap by turning it to the horizontal position. Wait until the Schlenk line has cooled down. Prepare the reagents required by weighing or measuring the amounts needed. Add all non-volatile reagents to the setup, and add a magnetic stirring bar when needed. Seal the flask again and position the needle that is connected to the Schlenk line far above the liquid level in the flask. Check that the flask is sealed except for the needle connected to the Schlenk line. The next step is to flush the system. Change between vacuum and nitrogen 3 to 5 times every 20 seconds by turning the tap of the Schlenk line. This process is called evacuation. Finish the evacuation with the tap in the nitrogen position. Add all liquid reagents to the reaction using the needles. Position the needle in or above the liquid and insert a second needle through one of the other septa. This second needle should be positioned far above the liquid level. Let the nitrogen flow through the setup. After approximately 10 minutes, the Schlenk line is ready to be used. With reactions using highly volatile compounds, the second needle is often removed to prevent evaporation. In addition to a dry setup, or under nitrogen, it is also possible to perform a vacuum distillation with the Schlenk line. The solvent or other volatile reagent can be removed when the reaction is finished. To do this, replace the septa with a stopper with a tap or gas inlet adapter. Connect the gas inlet adapter to a gas washing bottle with a short piece of vacuum tubing. Check carefully which end of the washing bottle should be connected. The other end of the washing bottle is connected to the Schlenk line. Place the washing bottle in an ice bath. Remove all needles from the setup and check that there are no other openings except for the tube that leads to the washing bottle. Set the Schlenk line to the vacuum position and start the distillation. All procedures shown are applicable on other types of setups. Details in the procedures may vary depending on the nature of your experiment.